The next problem. A rocket with a lift-off mass of 20 ton is blasted upwards with an initial acceleration of 5 meter per second square. Calculate the initial thrust or force of the blast. Okay. See here, mass of the rocket is 20 tons. 20 ton is what? 20,000 kg. Right. Initial acceleration 5 meter per second square. Now, acceleration due to gravity. Acceleration, just take it as 10 meter per second square. Okay, for easier purpose, let's take it as 10. Okay, now what we'll do, we'll use Newton's second law of motion. Okay, see, using Newton's second law of motion, F is equal to m into a, correct? But here, see, it's not just m into a which is acting on this, right? So we have F, the force, minus m into g, that's the weight. Because see, weight acts downwards, but your acceleration, whatever the force, the thrust, whatever you have to give, that should be upwards. These two are acting in opposite direction, right? So F minus mg is equal to ma, because F is the actual force, minus mg is because of weight, and then ma is the upward direction, right? So your total force F should be equal to mg plus ma. So m you can take common, m into g plus a. Now substitute. If you substitute, m is 20,000 into 10 plus 5, 15. So 15 into 20,000. So we'll make this into scientific form. So you will get an answer as 3 into 10 to the power of 6 Newton. So the force of the rocket, the upward thrust of the rocket is 3 into 10 to the power of 6 Newton. That's quite a lot. Okay? Now, so next one. So next one is a constant force acting on a body of mass 3 kg changes its speed from 2 meter per second to 3.5 meter per second in 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude and direction of the force? Okay, so this is the question. So take a moment and then try to see what are the informations given to you. Okay, see here they have given you the mass 3 kg, they have given you initial speed which is 2, final speed 3.5, and they have given you time in 25 seconds. Correct? Now first we'll use the laws of motion. See, final velocity, initial velocity, time, you know. Can you find out the acceleration? Using the laws of motion, see, we have v is equal to u plus at. Now, v is known, u is known, t is known. Correct? So, if you substitute, a is equal to v minus u divided by t. So, 3.5 minus 2 divided by 25. See, v and u, they are in SI unit. Time is also in SI unit, so you don't have to worry about it. So you will have 1.5 divided by 25. See, 1.5 by 25 is what? 0.06 meter per second square. Correct? So that is your acceleration. Now use Newton's second law of motion. F is equal to m into a. So m is 3, a is 0.06. So if you substitute, you will get the answer as 0.18 Newton. See, in this case, so see, in the question they are telling you that there is no change of direction, right? So the force also moves in the same direction as the velocity. Okay, so no change in the direction. Now remember, whenever you're solving any problem, so first write down what is the information is given to you, and then the SI unit, don't forget, and the formula. Okay, so these three are quite important. Okay, so in the later on videos you will see different problems also. As of now, these are all the problems which we used Newton's laws of motion to solve. Fine?